Alright, so product graphs are probably the hardest graphs to draw. When you're looking at A, you're looking at x times 2 to the x, and if you think of x getting really, really big, going to infinity, then it's just going to get really, really big. But what goes faster is 2 to the power of x rather than just x. So 2 to the power of x starts winning as x gets really, really big. So you know that 2 to the power of x, let's just draw that one. So 2 to the power of x looks like this. And it goes through x equals 0, that'll be 1. So this y equals 2 to the x. Whereas y equals x is your straight line. Well, that's not a very good straight line, but something like that. So the exponential goes up faster, of course, than a straight line. So it's going to start winning, and you can see wherever I've got a positive and a positive, it's always going to be positive. When I've got a positive here and negative, then it's going to be a negative. All right. So, and when I've got a 0, I'm going to get a 0. So this is 0 here, so 0 times anything is still 0. And we can see that as x goes this way to infinity, 2 to the power of x is going to start winning. So it's going to go up higher, steeper than the original 2 to the x, because it's 2 to the x plus a little bit more. All right. Now what's going to happen on the left? Well, we know that when x goes to negative infinity, if you think about it, it's the same as, so 2 to the power of, let's say x is negative, so I've got 1 on 2 to the x if it was a negative. Whoops, so I'm saying times that. So you can see, so this will go to 0, as it were. So it's going to get closer and closer to 0 as x gets bigger and bigger and bigger, but in this direction. So we know the curve is going to get closer to this straight line, y equals 0. And we know that it's got to be negative because there's a positive times a negative. So think about where it is at the moment. So it's coming down here. It's going to be negative, but it's got to go towards here as it gets really, really big in the negative direction. So it's going to turn around and go back towards that line. All right. Okay, so let's look at the next one. So we've got x plus 1 times 1 on x squared. All right, so this is a little bit of a weird one, but you can see that as x gets really, really big, you can see as x goes to infinity, that x squared is going to go quicker than x plus 1. So it's going to go towards 0. And it doesn't matter if it's negative or positive. All right, so it's going to go towards 0. So we've got this graph. We already know that as we go out to the edges, it's going to go towards 0 there. Now, if we look at each graph separately, we've got, first of all, y equals x plus 1. So let's say that's that graph there. And we've got 1 on x squared. Now, 1 on x squared, like a hyperbola, except it's got x squared. So it's going to look like this. And it's x squared, so it's positive, so it's going to look also like that. Yeah, because it's an even function. Alright, so what's going to happen? Well, as we said, it's still going towards 0, but if I go to green, we've got here positives plus positives, so it's going to be a little bit higher than it originally, because I'm adding a positive curve, so it is going to still do this, but it's going to go towards 0, so it's still going to have a hyperbolic right branch. It's just we're adding a bit more to it. So at this point it's up a bit higher because we're adding stuff to it. Alright, if we look at the left side, we do have positive times positive right up to until it hits 0. So 0 times anything is still 0. But otherwise it's positive, so I know it's going to go like that. Alright, and then it's a little difficult to see what happens here, but you can see it's a positive times a negative because these are positive y's, these are negative y's, so it's going to go under, it's going to be negative, but we know it comes back to 0. So again, I know it goes down, but it comes back to 0. It goes towards 0 as x gets really, really big to the negative. Alright, now if you get one like C, it's much easier if you can see it just to do, so we've got x on x minus 1, and what you can do is go, well, that's the same as minus 1 plus 1. So if I write that as two separate things, I have x minus 1 on two separate fractions, not things, and 1 on x minus 1. So that's the same as 1 plus 1 on x minus 1, which is nice and easy because we know it's this curve up 1. So if we're doing the original curve, it's a hyperbolic curve where x cannot equal 1. So originally, for x equals 1, it would have looked like this. And it would have cut through, so we've got x equals 0, so you'd get negative 1. But we want to add 1 to that curve, so everything is going to hop up one place. So if I redraw it, there's my x, there's my y. So the original horizontal asymptote is at 0, but it's going to hop up 1. So now it's at y equals 1. But I've still got this asymptote here, my x equals 1. So now it's going to look like that. And if this hops up 1, it goes to 0. So now it's going to look like that. So that's much easier than doing a multiplication. So if you can get out of doing a multiplication of two functions, then do it.